So we're pleased to welcome today Christina Paciuelli, who will be talking to us about linked open data. For those of you who want to tweet, we are going to just do the hashtag #LinkedJazz. So for those of you who want to have a conversation on Twitter about this, that would be great if you can contribute. So I'll just do a brief introduction, but before I do that, I want to thank Robbie Blitz, who has helped with planning this series, which is a part of our digital seminar program and our Digital Humanities Center sponsored talks. So Christina Paciuelli is an associate professor at the School of Information and Library Science at the Prague Institute. Her research focuses on information organization and knowledge representation methods and tools applied to information systems and digital libraries in particular. And she'll be talking again today about linked open data. So thank you.
Thank you for the introduction, and thank you for inviting me. Thanks all for coming. I'm delighted to see so many people interested in this kind of, I don't know, obscure, abstruse topic. An emerging topic in our area, anyway. What I'm thinking to do today is to start with an overview of linked open data. It might be redundant for some of you, or it might be awfully not too technical for others, and then give some examples of the application of linked open data to cultural heritage, and ending the talk today with sharing my own experience in crafting, forging linked open data for a project called LinkedJazz. And through this talk, I think some of the opportunities and challenges of building this new ecosystem of information will emerge. I also will be grateful if you can stop me anytime and make this more than a talk, just a conversation. But I will start with a general definition of linked data, which is a method, a series of best practices actually, for publishing structured data that makes it possible to interconnect, interlink data from different heterogeneous sources and integrate this data into a unifying global discovery environment. So linked data is actually the implementation of the vision of the semantic web. For those of you who have familiarity with the semantic web or have accumulated some frustration like me, or worked with the semantic web for a number of years, modeling very complex and logically formalized ontologies, but working on a project that would never materialize, linked data actually represent the actual implementation. And so we moved from the phase of advocating for a semantic web to adopting, to building it. One important implication of implementing the linked open data environment is the shift, the turn from an idea of an environment focused on the document, a document-centric perspective, towards an entity-centric perspective. And this is very important for people who deal with cultural heritage, because cultural heritage is made up of things like entities like people, places, events, organizations, anything, any topic. And so linked open data allows to focus, to apply representations to individual units of information beyond the document, and to make it possible to use that information that is currently hidden in documents and make it available, openly available on the web. And we talk about web of data as a new discovery environment. So when we think of a place where we look for information. In the context of linked open data, we think of the web as our database. And so, well, there is some disalignment due to the passage from Mac to PC, but I hope you don't mind. So linked data aims to connect more fine-grained bits of data. And the connection occurs through relationships, links. But these links are given a meaning. So usually they are called typed relationships, but relations that have been represented in an explicit way. So linked data is all about generating relationships. And if we think of connecting data at the granular level in new ways, we can start imagining, envisioning an environment where we are giving new opportunities to read the data, to read information, new paths to access, new ways to navigate information, and ultimately a new approach to interpretation. The success of linked data is due in part to the fact that it relies on an open framework and a set of open standards that are relatively easy to use. So basically, these are the main principles as Tim Berners-Lee has laid them out. And you have to remember that we are talking today about linked open data. So the openly accessible, openly licensed version of linked data, which is a community effort and is also endorsed and promoted by the W3C. So the three main components of linked data are assigning URIs, so unique identifiers, to things, giving things a name that is globally recognized. Use HTTP to make these names being visible. You can look up the URIs thanks to the HTTP. And so you can look up what the names refer to, either humans or software agents. And then these pieces of information, they are named, they are also organized within a model, a data model called RDF, Resource Description Framework. It's a common format. It's the model that creates this unifying context in which data can interact, interlink. It's important to spend a little time on what RDF is, because it's a critical technology beyond linked data. RDF is a language, is a grammar, with a grammar which is relatively simple. It's made up of statements that are composed by a subject, a predicate, and an object. So all we can say will be structured in this way. Let's say that we want to describe Thelonious Monk. So what we do is we have a subject. This entity here is given a URI. The URI can be taken from a number of sources, and we will see later. We say has name, the predicate, and object, Thelonious Monk. Now, if we translate in linked data, not only the subject has a URI, but also the relationship. This link is explicitly declared, is make it readable by the machine. And it's very important to think of where this URI is taken from. And if we want to say this entity has named Thelonious Monk, we will look for vocabularies, RDF vocabularies, established popular vocabularies in the context of linked data that provide as the source of predicates for us. And so has name will be taken, in this case, from a vocabulary called FOF. You might have come across this weirdly called knowledge tool. It means friend. FOF means friend of a friend. So we can take name from it. If we wanted to say Thelonious Monk is the creator of April in Paris, is the creator will be taken from another vocabulary. I would take it from a Dublin Core vocabulary where there is an element creator. And Dublin Core has many other vocabularies, including a lot of vocabularies from the libraries, have been converted in RDF format, so they're eligible as source of semantics for linked data. And so the result of our construction is a triple like this. These are the building blocks of linked data. You see here a subject, the relationship, and the object, Thelonious Monk. Thelonious Monk here is what is called a literal, so you don't see any links here. It's a literal triple. But if we put it in the context of the data structure, that statement looks something like this. But we can add any other RDF triples and start creating and gluing together semantics and linking things to each other in a way that is meaningful for the machine. By adding a URI here instead of simply a literal name, we will make it possible to link this portion with other statements. Does it make sense? Does it convey the idea that all the power of linked data stands in these URIs? And so what we have now, the information we have now on the web is connected through hyperlinks. But these hyperlinks don't express the type of connection between two pages. Yeah, these hyperlinks don't tell us which kind of connection is held between two documents or two pieces of data. They just say there is a connection. What linked data does is telling you the relationship is, for example, has name, is created, is a friend of. So using the LOD approach, a resource can be linked to any other resource by simply adding a triple. One of those triples we have seen earlier that just express relationship between the resources. With the traditional search environment, the linkages would be just left to the users to make. So you would have to, or we all would have to interpret these linkages, make inferences between data from different sources. With this technology, we are able to access information in a unified way. Visually, it would be something like this. It is actually something like this. You see a network of links. So you can navigate these links. There are different ways to access linked data. And again, now we can only imagine them. We have a few examples, but it's still in the making. But the way we access linked data could be by navigating them through their connection. And the approach is called follow your nose. All these linked data can be crawled by robots and then aggregated, integrated, and a number of things can be done on that. So this is how RDF triples are woven into the fabric of the web of data. And then they can be navigated, as I said, or crawled by the robot. Well, this is the most popular way of visualizing linked data. How many of you have seen this cloud. It's everywhere. Every time I swear that I won't show it again, but is still powerful. And what we see here is a number of nodes. Each node represents a data set of linked data. Each node holds massive amount of linked data from various sectors. Now, government data have really grown incredibly, and so they occupy a big chunk of this cloud. But libraries have been contributed linked data in the last few years. 2010, I think this cloud grew 1,000% thanks to the library's contribution. And this is an old picture. It's still stuck in September 2011 because the cloud is growing and they haven't figured out a way to visualize so much linked data. But what happens here is, or what this picture conveys, is the idea that all these data sets are highly interlinked to each other. And what is really interesting is when triples are connected to other triples from one semantic area, one domain to another. Is where the synapses, interesting synapses, can occur. I was thinking of what are the benefits of linked data, and there are four aspects that I think need to be stressed. The idea of sharing data, the idea of reusing data, the discovery of information, and the integration of information. And I think at this point, sharing and reuse is something that has become best practice, and the linked data community is doing it heavily. It's one of the ways you create link, by reusing what is there. You remember when I mentioned the faux vocabulary, you take semantics from from where it is already. So share and reuse is something that we are doing pretty well. The integration and the discovery are where the research challenges lay, and it's where also research has moved its focus now. So people have worked in the last few years. You have to think that linked open data started in mid-2007, so it's relatively recent. They've created all these huge repositories and put them available for the community to use, and now is the time to build interfaces or to build tools to consume this data. One of the most important repository data set of linked data heavily used in the linked data community is Dbpedia. It's the biggest one because it's derived by extracting information, structured information from Wikipedia. So the magnitude of Dbpedia reflects the magnitude of Wikipedia. And it's a semantic hub where everybody is taking linked data. Because there is everything. It's a general repository, and you find anything there. There is the implication of dealing with a repository, dealing with data. They are contributed by people, by volunteers, so the quality is not always the most accurate, but certainly the wealth of information is incredible. And in this case, I pulled up a human-friendly, user-friendly view of Dbpedia. So this is a page for Columbia University. It's much longer, but you see all the possible linkages from here. And how typically linked data looks like is mostly code like this for developers. But in this case, you have the possibility to browse information and to see a number of linkages and the type of representation that Dbpedia offers. Well, in the certainly with this idea of putting their data available for others, the New York Times has been a pioneer. They converted their historical index into linked data a few years ago. And you will see a number of these data sets where the data are available for people to build their own applications. Most of the time, the data sets are for being used by someone else. The New York Times did a wonderful job in also offering APIs, ways to access this data, broken down by articles, by geographic information events. So it's a very curated set of data. The Library of Congress has also put their authority files available as linked data, and the libraries have really contributed a massive amount of high quality linked data, which is not what Dbpedia provides. And so the data that you get from the Library of Congress are typically the ones that you use for increasing the quality, the accuracy, the consistency of your own data. And so you have, for example, the authority names with the URI, the naming, and all the variants and related terms. So I think the libraries have never been as popular among developers because it's really their tools are a point of reference for everybody developing linked data. But most of the time, you see the data that look something like this. The British Museum converted their entire database of objects into linked data, and again, is open for people, for grasp, for people to use it. And the only interface they provide is this one. It's pretty scary, and it shows actually the query system that linked data uses, which is called Sparkle. If you hear Sparkle, this is the language to query this data. It's a derivation of SQL, but is made in a way that it can query triples. So now we need a little imagination. We can only envision the benefits that linked data could bring to the discovery of information, the interpretation, the use of digital heritage. There is a massive amount of semantics out there to be consumed, to be exploited. What people are doing now is developing in the form of prototypes, creating working prototypes, creating use cases to discuss, proof of concepts. So I just have a bunch of, I've selected a number of examples that they give us a sense of what is possible. But again, it's just the beginning. And so let's start with Canadiana, which is, I think, a consortium in Canada of cultural heritage memory institutions that they want to integrate, share and integrate their objects. And so they started with creating a proof of concept called Out of the Trenches. So they focused on First World War, and here there is their idea of integration. The quality is not excellent because this is a screenshot from the video they put online. And they are working on this, but this is a way to demonstrate the value of using linked data. So in this case, by aggregating, integrating, pulling together metadata and data from a number of sources, they were able to, for example, create a history or the story of this soldier. So the sources are for example, the repository of war poster, the repository of war songs. From the authorities, they got all this biographical information, the date of birth, death, the place, and a number of other documents. Could be, well, photographs of the soldier before he left with the other members. He was part of the Black Crow. With other members, letters. The first letter is sent home, clippings from newspapers, because these are taken from a collection of newspapers, and it just gives you a sense of what can be done. Things can be aggregated, putting together, and creating new stories. Now, these are all the participants' organization. In this case, the aggregation, the integration is done by mapping the metadata from different institutions through this model, mapping against ontologies, RDF ontologies. It's not the first time we see an integration of documents like this. What linked data brings to the table is the fact that you don't need, for creating an integration system, to hardwire your semantics into the system. But the approach doesn't require that you define, for example, the linkages a priori in advance. And so you can, even for the metadata, the protocols that are used, they don't need to be agreed upon in advance. So it's a completely different method of work. You use what is available. You can cooperate, obviously, but without the need to coordinate, to come up with a preemptive agreement. You use what is already available because it is in a format that is kind of a lingua franca. Does it make sense? Does it start to make sense? Other examples. This is the Rijksmuseum of Amsterdam, in collaboration with other memory institutions in the Netherlands. They created this as a working prototype. Well, it's a service, probably a full-fledged service, where they decided to offer the possibility to aggregate documents, pictures, or objects according to the spatial dimension, with the idea of offering the end user the possibility to create new story and have a new approach or a different approach to the interpretation of these objects. But this is only one possibility. Space, geospatial data are available and are heavily used, but there are a wide range of possibilities to aggregate objects. Another example is this Open Images, which is a project, an open media platform where people can access videos and photographs. And this is another repository of objects and linked data that is heavily used in the interlinking with I think again the Amsterdam Museum. The only condition is to make this stuff available in this format. And then you can take your triples and you can interlink them, as we saw earlier. The Amsterdam Museum is probably the institution that has done most. They have converted everything into linked data, and their data sets are heavily consumed and used for example, semantic mobile 2 wraps and many other services. This is only a way of showcasing possibilities. But again, almost all the initiatives are still in the beta stage, and they are prototypes, and everybody is working on creating new services. So you have a sense of this potential that is there, and relatively easiness of doing linked data. Obviously, there is a learning curve, but it's truly something that you can accomplish with a little Python programming knowledge and some knowledge of this kind of modeling environment. Now, at this point, I would like to share what I've been learning in the creation of linked data for a project I work on for over 2 years now. It's called LinkJazz, and it was initially funded by OCLC, and it was, for me, actually a way at the beginning to experiment with this new technology, kind of improvising in the jazz environment, applying this technology to digital archives to jazz history. And I'm showing this because it seems to me it could be useful to give the sense of the challenges that we have in digital archives. We know that digital archives might have very poor metadata, if any. The jazz history archives are terrible to this regard because they have not much stuff digitized and available, and what is available is mostly to showcase their collection, but it's not that you can rely on good metadata. It's only the libraries that have this tradition of, first of all, collaborating and sharing metadata and creating high-quality metadata, also because they deal with standardized, they've been always dealing with standardized documents. So they've been so active in converting metadata and providing to the community with this accurate representation, but this is not the case with museums that deal with unique objects, and they have another way, another approach to access to information, and certainly not archives. Traditional archives, they have descriptive tools that describe at not at the item level, let alone at the data level, so at the collection level, and they can be of little use in the linked data environment. So we went all the way from the beginning and just following all the steps of creating, forging, crafting this data with the purpose of being able to link networks of people to networks of information. In other words, with the idea of uncovering, representing the dense network of relationship, personal, professional, social relationships that are held in the jazz community. Something that is very well documented in discographies, in the literature. It is very difficult for the user to capture, at least on a large scale. So what we wanted to do is to create a tool that helped to identify and make explicit this network of relationships from oral histories. We work with text, interview transcripts. This was our goal. Then we started from scratch. Well, also, no, the goal in a broader way was to create a tool that was useful to researchers and also for public engagement, for reading and analyzing the history of jazz in a new way, and also ultimately contribute to the linked data community by exposing archival data to the web for other people to exploit and to make possible to create these cross-domain interlinking. So all we had to deal was text, some digitized, some just given to us as manuscripts. And so the challenge was how we identify the names of the people here, which is the first step for extracting name from documents. So we have this text, and how to find out what names are here, because our assumption was if someone here in an interview cites someone else, it's very likely that this person has some level of knowledge of the other person. It could be just knowing the name, or being a close friend, or being a collaborator. We don't know. But there is some kind of linkage there. So the first step was create a name directory of jazz musicians. Then use this directory to match names from the transcripts and convert these matches into RDF triples. One of those triples we saw earlier. Well, what we found ourselves doing was a lot of data preparation, data analysis, data curation. And I'm assuming from what I see people doing, this is what you should expect to do at this point when you work with linked data. There is kind of a convergence in building tools for cleaning up data, for mapping data. And they are the first generation of these tools. Probably in a short time, these tools will be available for others to use. But when you work with linked data, you need a way to create a sound set of data to work with. So first of all, create a name vocabulary. My first choice would have been the Library of Congress authority names, but it was not converted into linked data, I think, yet. But in any case, there is no way to detect the role of in a authority name, because you don't know which one is a musician. Only occasionally you have the role stated. So it was not possible to use this vocabulary. And then we had to do a number of other steps, like mapping, and build a number of tools, mapping a curator, visualizer, crowdsourcing, and transcript analyzer. I will show them briefly just to give you a sense of what is needed and what is also interesting to build. So we needed a vocabulary that was made of these statements. For being able to assign URIs to all these people. There's the first step. The natural choice was Dbpedia. In Dbpedia, there is everything. Very few musicians, obscure musicians, are left out from Wikipedia. So you have to extract data from Dbpedia, and you hope for the best. Well, we were able to create a directory of over 9,000 musicians, so a pretty decent directory of names. But it was and is still incomplete, because you have pretty good, we would say, preferred name, uniform name, or preferred, because they are extracted from this portion of the info box. You recognize the info box on each of our Wikipedia pages is where Dbpedia extracts its data. So it depends on the quality of the data that are provided by the volunteers. Typically, the names is good quality and is always there because it's a mandatory field. But when it comes to nicknames, stage names, all the variant forms of names, it's not reliable. Who wants to put the actual birth name, or most of the time people don't know this information. So what is here is kind of not high quality data. So the next step was to have a way to normalize our data and enrich them with the variants. And so we built a personal name mapping tool, and here we see the interface to a heavily automated process where on this side, we have our directory, and then we have the possibility to map against Library of Congress, VF, and also Wikipedia names. This process is done automatically, and these are the results. So you have different levels of confidence. In this case, you have a perfect match. Mary Lou Williams, date of birth, date of death, corresponds to the Library of Congress. This is done. But then you have different levels, but you also have the possibility to manually verify your data. And I think one piece of informational lesson that we received from this experiment is that a mix, an hybrid approach, machine-driven and human-driven, is the key for creating trustworthy data sets. So you can verify manually. You have, in cases like this, Avishai Cohen, we have two Avishai. The machine cannot really say which kind of Avishai is referred by our vocabulary. And so by looking up the Library of Congress, you see that one was born in 1970, 178, and boom, you have your quality, perfect match done. So these kind of tools have been built for the purpose of linked jazz, but they are basically domain agnostic, so they are mapping tools that can serve a number of purposes. And so it's kind of, I would say, the first generation of tools, but I see NYPL, many other institutions or initiatives, they are building things like this because they are needed. And then you get your own kind of authority record, I would say, but anyway, your name enriched with all the possible variants. It's obvious that if you have all the variants, you can perform a better mapping against your transcript because people can be cited in many ways. And then this probably is the tool that gave us more satisfaction because it shows up your your musicians in their social network. And again, the visualizer is an interesting tool, browser-based, so you don't have to plug in anything, download anything. And it shows many views, dynamic and fixed views of the social network based on the data set. Now, sure,
So,
yes.
So we can't really infer anything about the nature of those relationships yet, right?
No,
And
not yet.
Sometimes they may actually hate that person. Dwight mentions it all the time.
Absolutely.
Just checking.
Yeah, that's actually, at this point, we could only say that the relation between these people is of knows of. Taking this predicate from another established RDF vocabulary called relationship. I don't think we can say anything more, but that someone knows of someone else, yes, because if it's this person cites someone else, it's very likely that at least they know the name of the other person. But that at this point, what we want to do in the spirit of linked data is to give meaning to these relationships. Now they are implicit. They give you, most of the time, social networks, they stop here. So you can do some pattern analysis, but frequency, closeness, but we want explicit semantic. We want to know which relationships are held between these people. So at this point, the machine is done. You have to employ a human-driven approach. And we are doing by creating a crowdsourcing tool that asks people to interpret the nature of the relationships based on the transcripts. So and that's why we build I'm saying we build, but to be fair, all these tools are built by one of our students, Matt Miller, who is a phenomenal developer. And so thanks to him, we have the possibility to showcase all these tools and to see linked data happening. Otherwise, it would be still the kind of only tied to the vision or imagination. But the Link Jazz 52nd Street is the crowdsourcing tool that allows to map the relationships between jazz musicians based on human analysis. This tool is under user testing these days. And what it does, it gives, the interface has already changed, but anyway, it gives a selection of interviews, and people can pick what they want, and they are presented snippets of the transcript, answer questions, structure, and on this pane you have all the people that are mentioned in this portion of the transcript, and we ask the user, the volunteer, the contributor, to pick one of the relationships from these option menus. And we also give an incentive so they can see that they are contributing to creating the network. So this is our way to harness the knowledge of jazz enthusiasts, jazz researchers. But to get to this point, you need to work on the preparation of the transcript. The transcripts don't come broken down into Q&As, and they are pretty messy, different formats, even if they come from reputable digital archives, Smithsonian, Rutgers, and Michigan, and Hamilton, and Amber. But still, no, transcripts are what we want to be able to say is, in this instance, the relationship Mary Lou Williams played with can be expressed by the predicate collaborated with from the MO music ontology. So these are all the some, there are many other possibilities, but relationship that can be recorded into linked data. So here is a spectrum of possibilities of things that can be said about the link between two people. Knows of, knows by reputation, knows in passing, has met, knows acquaintance of, close friend of, influenced by, collaborated with, mentor of. Obviously, the nuances or the expressivity of this relationship is tied to the options we have. So what the vocabulary can say, yes.
Right. So how standardized is that vocabulary? What's the namespace and the provenance of that kind of terminology? Or is this just
the namespace are the FOF namespace, for example. This is a very, well, it's one of the most adopted, established vocabulary. Or REL is a relationship vocabulary. Music ontology is a very established vocabulary. And so these are the vocabularies that say something about the relationship of people. There are a number of vocabularies, but these are the most established. And the more established your semantic is, it's more likely that you can support, enforce, enable interlinking. Yes?
For jazz musicians, wouldn't it be important to know whether they played with them or composed with them instead of just collaborated with?
Yeah, it's true. This kind of information is yes, it's important. It's offered by discography. It's something that you can certainly find out just by mapping data sets. We did it. The collaboration, for example, we did it with other data sets. But you cannot understand or you cannot get the social relationships. Well, you have, yeah, the collaborated, it's true, that can be found. But what we did actually here, and it doesn't show here, but you can click on collaborating and you have different nuances of collaborations. But it's also true that collaborated with is kind of the low-hanging fruit. It's not a great discovery, too, because it's obvious from the discography. And it can be performed automatically. We use this because from the feedback we receive from jazz musicians, more than jazz musicians, jazz historians, this is a critical relationship for them, and so they want to see the nuances. Yeah. But, well, this is the final tool. So when I said when the transcript needs to be organized, structured, built up in a way that you have these snippets of information, of questions and answers in sequence, and all the people on your left, they are mentioned. So this is not an obvious task to accomplish. And this is done through another curatorial tool called Transcript Analyzer that I'm sure I'm giving a very sloppy description of. It's quite complex, actually. But but for the user, it's easy. You upload your transcript, and you map your names with the directory on your left. Basically, through a natural language process methodology, all the names are identified. The blue names are easy, not problematic names. But when you have a buck, really, you need some kind of curation. And what the tool allows you to do, among other things, is to reconcile the partial names when there is a full name in the neighbor, or to have a way to look up through authorities or other sources And it's able to, in this case, this is what it did, and then you map against this. And this tool is able also to identify other kind of entities besides names. And it has a high performance value, so it's named entity recognition of some help when you deal with textual documents where you need to identify cities, places, periods of times, or names.
And does it have some user interface, like when you get to
Yes.
the case of like Chano and Chino Pozo, which are commonly misunderstood,
This is
right? They were cousins, but they not the same people, and frequently the music of Chino is attributed to Chano, but Chano was already dead. Right?
well, in this case, you disambiguate the names, but you can do some search. If you are really desperate and confused, you can look at you can look at the web and basically, yeah, map your names. It's pretty rare that we find names that are not anywhere. Even the most obscure musicians have entered the Wikipedia. But at this point, well, what is left to say is when we started to put together a catalog of LOD open issues and ongoing challenges. And so we can just very quickly, I can just mention that there is a need for more applications that consume this data. We saw that for now we have prototypes and people have started to work on that. Need for user-friendly visual interfaces as entry points for users. Obviously, users cannot interface, for example, the British Museum data through a Sparkle query window. There is a need for method and services for enforcing the data quality, and is what a lot of people are doing now to enforce integrity, accuracy, trustworthiness. For example, in our triples, we add another line to state the provenance of the information we provide. And so this is because we think that for archival context, it's incredibly important to give the source of your data, and also for the statements that express the relationship from people. We want to be able to say, well, this person is a close friend of this other person based on this source.
Christina?
Yes?
Sorry. You mentioned all the tools, and you mentioned that they're generalized to other projects with linked data. Where can we get the code on
The code is available, in part is available on our website, and everything we are developing is open access and is shared. So,
your website?
in part is my...
You're getting a lot of questions from out there in the
Yeah.
universe about this. So if you could put it on GitHub, that would delay numerous people. There was something
Yeah, the code that is not available yet is because we are working on the tools, and they have not been launched yet. Like the crowdsourcing is in the phase of testing now, so it's not. I mean, I think we will launch it in the summer at some point. What is available is our vocabulary. There is a file at this point on the website with all the names of the musicians we recorded as triples, and everything else would be available. Well, and just to really end the talk, there is well, this is one of the challenges I have talked much about, but there is a need for query methods that scale across the unbounded web. So far we have seen the interlinking of well-established data sets Dbpedia, Library of Congress, GeoNames. These are very, very, very reliable data sets. But the interlinking in the open web, this poses some issues of scalability, especially because the Sparkle query language is probably not strong enough. And this is a matter of creating a layer of a stronger functionality in terms of querying. And finally, as for the opportunities, I was end with what someone at the LODLAM summit 2 years ago said. It was LODLAM is this community of linked open data for library archives and museums. It's an emerging community, self-organized, where people get together every 2 years to discuss the development of linked open data. And I think the spirit of linked open data is captured in saying the best thing to do to your data will be thought of by someone else. So we put out data, we build some applications, but it's not a prescriptive environment. You don't prescribe how this data will be used. So someone else might have much better ideas on how to make the most of these semantics. I think it's pretty much what I wanted to share. Thank you. Questions?
I think it's early with the crowdsourcing tool, but are you planning to do any kind of evaluation, whether manual, automatic, semi-automatic, of the contributions you get back from the crowdsourcing?
Yes, we are designing a study to evaluate the contribution, to evaluate what it takes to create an effective crowdsourcing tool. So what are the motivations? What are the features that can engage users? What are the elements that are important to create this connection between a community and the project? And actually, we have a paper coming up at the Digital Humanities Conference in July about the design issues and features of a crowdsourcing tool. And yes, it's extremely interesting to see. And from our point of view, the harnessing of the knowledge should be balanced by offering the possibility to learn. And so that's why we are designing new features in a way that the volunteers can also gain a reward in learning something new and also building communities. So there will be features, spaces for comments, for providing their knowledge, but also to connect. And it's a very generous community, and the initial feedback was very positive. People are expecting to work on this tool. And so, yeah, that's evaluation is it's an ongoing activity with these tools. Now we are testing the interface, just the usability of the interface. And then we will, yes, Alex.
What has been the uptake so far by scholarly experts, and what do you expect it to be the scholarly use? I ask in particular because it does seem like a very useful entry point research reference source in the future, and that's what it will be when you're an undergraduate student. It's about to start writing a paper, and then you want to start seeing some of these links, right? But then you want to move up, or they're going to be required to move beyond those initial connections. But have you worked with scholars already who have said, "Oh wow, I discovered this thing that I didn't know"? Or do you expect that to happen?
We are hoping that this happens, but we got good feedback from the people who have been interested in it. Actually, surprisingly, probably because of the social media, but the jazz community in New York is looking at this stuff. And there are a number of people working already on this crowdsourcing tool that is not been launched yet. So when you see the blue, there was the blue under some of the transcripts, because people, they started to work on analyzing these relationships. I don't know what we are going to do with this data, but people are already naturally engaged. And I think also in our group, now I work with students, our students at Pratt, they're fantastic students. We have jazz musicians. That happens in New York. Some of your students are musicians. And so they have direct feedback from them already. One is a musician, but one is a journalist, is a jazz journalist. And so he asked directly to the community, and we are expecting engagement, but no, we have also to work hard to offer features for engagement. Yeah, and we talk with a number of researchers, Columbia, at Rutgers, and they showed interest for tools that have to analyze data in a new way. And you have to think that now we are doing the hard stuff of analyzing the relationships, but hopefully we will be able to aggregate many other pieces of information, even songs and dates and events together. This, we think, is not the hard part. It would be the fun part, but the hard part now is to find out what is the nature of the personal relationship between people. Yeah. Yes, Jenna.
This makes me think of, I'm working with a group of zine librarians to build a zines union catalog. And I was thinking that, could a linked data project be an alternative to what we think of as a library catalog, where it's just, an aggregated space and you link out to the different holders?
Well, the library community is positioning towards working with linked data with the new BIP frame, and so it could be certainly an extension. Like linked data, in relation to the web, to the traditional web, it's not a replacement. It's just a new layer of semantics. It's an extension of the existing web. So nothing is going to change if you don't want it to change, but you have these new opportunities. So I think for the library catalog would be the same, especially with the new standard RDA, with all the work that has been done in converting legacy data, legacy metadata. So I think it will be an environment where we will see more and more of linked data. The librarians have invested enormous expectations and energy in this. And that's why I think that compared to the semantic web that never happened, linked data has involved so many parties heavily. And so it's a matter, I think, of emergence. At some point it will emerge, and I think we are very close to.
What is OCLC?
Well, OCLC is, well, they funded my project at the beginning. They are very interested. They are doing themselves a lot of work. For example, with VIAF and a number of initiatives on names. So they are working on linked data.
And they're exposing and sharing their own data? Not so much, okay.
It would be probably linked data, not linked open data. But I don't know, really. I haven't explored the openness of, but I know there is a lot of research going on. Yeah, please.
So my question basically is, what is the relationship between metadata and linked data? And is it how easy, for example, to convert metadata, let's say like doubling core or mods or meds to, what is the standard in linked data?
All these all mods, doubling core, if they are converted into linked data format, they become linked data. I don't know if there is a need to really make a distinction between data and metadata at this point, when everything is translated in a common language. And so the Dublin core can offer you the predicates, create, or subject, or whatever element Dublin core has to offer to say, Thelonious Monk has subject, and then you have the subject heading from Library of Congress in your URI format. So it's a way of interlinking all this information according to your needs. So metadata and data becomes interlinkable and usable.
So, but you don't use XML in data.
XML is just a serialization format. So XML can be it's the syntax of RDF. So it's the way you express an RDF. It can be through XML. It could be through other formats. One is Turtle, one is JSON. I mean, there are different ways.
I'm sorry, you said Turtle JSON? I mean,
it's a form of expressing, is a syntax for RDF, XML. So it's.
You can express it in another format, not in XML, but you can express it in something else.
You can express also in something else. They're all. Yes, it's an easy conversion from an RDF/XML into another format, but it's all code, and all these triples will work together pretty well. So what I'm saying is the boundaries of the institutions are becoming more blurry. And this is one of, I didn't want to bring up the silos buzzword, but it's really what linked data allows us to do, to break down the institutional barriers between memory institution, if we think about cultural heritage. So who cares if the description of a museum object is sitting in a digital library database, or everything can be mashed up. The idea is mashing up, but not the way we do mashups now, where we have closed systems, they don't talk to each other. Since they don't have a common naming method, you cannot link different mashup systems. With linked data, you can perform truly mashup between museum, libraries, archives, and the external world. Yes, Alex.
So that brings the problem. I mean, one of the critiques of linked data is the idea of literals, or the quintessential problem of the URI. So when I say, for example, what is the Atari game E.T., right? This was a problem posed by a philosopher, Ian Bogost, who is the game theorist. Well, it's a cartridge. No, it's just a series of codes. No, it's an interactive experience that we have when we play. No, it's actually just a brand name. And he proliferates the list in a Borgesian way. It's actually Borges' own problem with categories. The dog, what is the dog? You know, if we build, I imagine a world in which it would take us like 100 years for us to map out everything, every object, and still we would have missed the boat.
Well, you mean it's a problem of identity of objects?
Yeah.
And, well, you give context to your statements. You make claims with RDF. They are situated in your language. So if I say something using a Dbpedia identifier, it's situated in that context, and the trust that you provide is raised to the level of trust that data set. But then you create, and I don't know if Alex, if I'm answering your question actually. Well, you know, there is something to be said with linked data. Linked data works with a level of tolerance that was not possible with semantic web, where these hard problems of identity were dealt with very complex logical languages. We got rid of these languages because it can work, a logical formalization can work in very constrained domain. But in our context, has been adopted a more flexible approach of, would say, good enough. You make assertion of similarity. You say something is the same as something else with a close match, without too much formalization, because it works well enough. So it's a problem of modeling. No, all models are wrong, some are useful. How rigorous you want to be, as much as your tool works. This is the approach of linked data. This is kind of a relief that people working with linked data feel.
I like it.
I don't know. I mean, it's a new way of working with messy data. Linked data is full of messiness, semantic noise. We just try to deal with it, building tools to map up things and to tolerate more messiness than a control environment. Is a trade-off between a control environment and an open database as the web. And it's one of the challenges, actually, but no. Thank you. Other questions?
Thank you so much.
Thank you.